So my name is Joseph Rapp, and I'm one of the educators here at the museum. So the shop was located in this limestone building in Bellevue, and this building is still standing. And we do have visitors who come through who remember seeing this building with a different name on it called Brandt's Garage, because after Mr. Brandt and his family ceased the manufacture of their boat engines, they switched to doing some automotive repair, and then most of this sat unused. So in the early 2010s, some of our staff and volunteers went down to Bellevue. They went into the original shop. We have a couple of great volunteers who were able to start up the air compressor, let it build up, and then they started up the line shaft system as if it had just been shut down a couple days before. But the family members who inherited the shop were not people who had worked in it. So the building itself was in need of some repair, and they had to decide what to do. So all these machines could have been auctioned off, they could have been scrapped, but the family chose to work with the National Mississippi River Museum and Aquarium, the Dubuque County Historical Society. And because the Dubuque Boat and Boiler Works had been sited outside here along the harbor, everyone saw the great potential to bring it here. So it took several years. It took the involvement of several very generous donors, benefactors, capable staff, and especially one gentleman whose name is John Bowditch, who helped us with the setup of this exhibit. We don't have a set of his blueprints or drawings for how he assembled his. And it's very possible that Mr. Brandt was able to buy an engine that someone else had built and was selling, taken it apart, measured those parts, and figured out how he and his son and a few other workmen were able to improve on that. So one of the things that this shop really excelled at was doing things so efficiently for a small price, because they compete against larger shops in other cities across the United States, on the East Coast and in the Great Lakes area. So one of the engines that we have is described in an advertisement that Mr. Brandt put together for 1922. The price was $85, and they were able to assert the fact that they were able to reduce the price significantly just by the innovations that were within this particular shop by itself. So the line shaft is about 40 feet in length. The first time I saw this, when I walked in to see this exhibit, I thought, that's one immensely long rod that's working all this. But when you look at it, you realize there are individual rods that connect to create something that is 40 feet long. And then there are small counter shafts for individual machines and their belts. All these brown belts are new composite material ones to replace the original heavy leather ones that they repaired over the years, and we do have a couple of examples of those. So when they were operating, they would move these brown levers, and the mechanisms for moving these small counter shafts would allow them to engage a small clutch in some of these, or just simply move so that the belts themselves, with a little bit of pieces of wood like a guardrail, so the belts would move from one pulley to the next one. This is really all very simple way of doing things, but yet it was so effective and allowed for the creation of so many more machines that could create more machines and build these engines that they were manufacturing. So one of the things that occurred with this shop, because outboard motors became more common and people were buying those, so they ceased production of their own inboard marine engines, and they adapted the shop to the repair of automobiles and trucks. and they used these machines to craft the parts as they needed to do whatever repairs they could do in the 1940s to the 1970s. And they also did some custom work for other people as well. They were able to use calipers. So some people that come into the shop here as a visitor, they see that we have calipers, and calipers are extremely precise to get these pieces made within a hair's breadth of a measurement. But there are micrometers and there are other advanced ways today of measuring, and that really in itself is a huge revolution in how you measure these parts to be able to get these machines to precisely shape those pieces that would fit into those engines. So it would have been an exciting time to have been alive to be able to do all of this hands-on. You didn't have a computer doing anything else for you. It was you, the machine, your measurements, your own mathematician skills, all of that to be able to do all what was necessary. And today, this runs on an air compressor by electricity, but originally the family had a small coal-burning burnt boiler to boil the water to make the steam. So when this is in motion, it's going to be going about half as fast as it did in the original shop. But the belts and the pulleys were actually a development from over 200 years ago in Massachusetts. And the first line shaft system was a very small one that was on the floor of a shop there. How many machines it involved, I don't know. But they were eventually suspended from ceilings. And that way it allowed for the placement of various machines as they were able to work on them in different places, whatever those settings were, whatever they were manufacturing or moving. But this shop with each of these machines, they were for metalworking. So before anyone had invented any of these machines, before anyone manufactured these, you went to a blacksmith or you went to a coppersmith or a tinsmith, but especially a blacksmith to get objects made that you were going to be using for whatever purpose. I bet most of the people that are watching this have seen or have heard of sewing machines that have a treadle. So powered by foot. And then there are today, and there have been wood turning lathes powered by a treadle. But these lathes to turn a metal part to create the shape that they needed to be were powered by the small engine here. So they are called specifically engine lathes regardless of how old they are. This engine lathe is from 1855. It's the oldest of the lathes in the shop. But after 70 years, somebody added an electric drill to this. The legs on this, if you're familiar with Grant Wood and his painting American Gothic, since Grant Wood was an Iowan, we like to give a little plug to him, but the windows of the house in the background in American Gothic look like these legs. So this one is from 1855. The next machine is a hacksaw, and that would have allowed them to cut through much more of the metal stock that they needed to work on to make the metal parts that they were doing. The drill press there, 1910, much larger than what it was needed for, but that was available to use in the shop. And then the engine lathe down there is more modern than this one, but that one has a grinder on it, unlike this one. So you see a development in what manufacturers were doing, is that as they were making these machines, they were adapting to what their customers on shop floors and factory floors were saying. So there are even a couple of these that have little metal plates that are attached to them with listings of numbers, measurements for the machinist to be able to use right there as he was working at that spot. But that one with the grinder on it, there is a wooden drum suspended from the ceiling down there, and that would allow for a round belt to go to the grinder. So they could move the position of the grinder as they needed to as they worked on that. But each of these machines had the ability or the capacity to have them adjusted by just using a couple of levers by hand or a couple of wheels. But for this shop, if you look up for the exhibit, you can see the jagged edges of what would have been the floorboards for the second story. So on the second floor, there were woodworking machines and tools that they would use for crafting the wooden racing boats that they excelled at building, as well as small work boats, small fishing boats. They built a few other boats that were at ground level outdoors behind the original shop. But they raced with their boats, and they used these engines to race. They sold their boats to other people and tested them out. So one of the records, because if you were on the river, you either had paddles, you had rows to row the boat, you had a paddle wheel on the steamboats in the 19th century, you had other methods for propelling, for moving a boat. But for the boats that they were building with these engines, they achieved in the year 1908 a speed of 36 miles an hour on the Mississippi River. And then a few years after that, they achieved a speed of 50 miles an hour in one of their own racing boats. And we have a great photo on the advertisement. They were bragging about how many awards they had won, or others had won, with their engines in their boats. Developed as they were set up, they were suspended from ceilings. And this is a very large one because they have been used, and some people still do use these line system belts and pulleys on the farm setting, for instance. There are still Amish-owned cabinet-making shops that use woodworking machinery with a belt and pulley system, but not powered by steam, but rather an air compressor running on gasoline. So there's an adaptation there. But these systems were used into the 1930s in the United States in many places, according to so many different visitors who either had heard about them or had seen them themselves. And they were powered by steam into those time periods. And then they started to fall out of favor when air compressors and other machine methods were available. So in a shop here in Dubuque that was used during World War I, there's a great photo of a woman underneath a line shaft system at the Adams Company, which is still operating in Dubuque. So during World War I, there were men who were called out of the factories and off of farms to serve in the military for that time. And there were some women who were called into service in some factories. So there's a great photo that shows a young woman, we don't know her name, but she's seated at a machine with her long 1916, 1918 era's dress with a line shaft above her, and she's working at a machine. Not ideal safety, but it's a beautiful photo that shows something unusual compared to who was using most of these machines, and that was at the Adams Company just a block away from here at that time. So other line shaft systems, if you were to go into, say, a restored saloon or a tavern, and there is a ceiling fan system, there are retro ones and there are some original ones that have a little line shaft system to operate those. But there would have been also some of these factories, when people were busy in them, as hot as they got, that ceiling fans themselves were even powered by belts and pulleys. To use water power preceded using steam power, and I don't claim to be an expert on steam engines or the development of steam power, but with the use of burning to boil water to make steam, people were able to use that as an application in so many different ways. So for instance, if you visit the River Museum today or in the summer, we have a large paddle wheel that is from our Women Black dredge boat, and that paddle wheel, when that turns today, is mechanized by electricity. But when it was on the boat itself, it was powered by steam. But there are places, and there are not very many, where a paddle wheel like that was used for milling grain into flour. And there are, in Bellevue, close to in the town where this shop came from, there is a place that has been historically known as Potter's Mill that has had a water wheel, and there are other places across the Midwest where places where that kind of a technology existed. So if you decide to come to visit, and we hope that you will, you'll be able to see this in motion, and we'll be able to see some of the machines in particular in motion. We'll show you one of those in a moment. So this is a metal planer from about 1855, and there is a cutting tool right here that can be lowered to go across the metal bar, and it can make keyways or grooves to flatten the surface. And however that piece was going to fit into the engines that this family was building is a matter of question. But this belt is crisscrossed because it's going to allow for a changing of the gears here, so that the bed is going to go back and forth after I move this shipper lever. And when we watch up above, there's a counter shaft that will move just a little bit. You'll see the belt moving just a little bit. You're going to see the three wheels down here. We have an inside one and an outside one, that when this switches gears, each of those are going to switch their directions, but this middle wheel never switches direction. So on this one, there is a large clip right here, and there is a large clip here, but underneath there are two little levers. So when those large clips interact with those two levers, which in the modern shop today people have told me they're called limiters, it's going to force a changing of the gears so that the belt is going to change, and then the wheels are going to change direction, and it's going to go back and forth, and it's going to smooth off that part to fit into that engine. And this is, again, a metal planer from about 1855.